Okay. So we're going to be doing one Leetcode question and then doing some scheduler development. I gotta boilerplate this up. Tokens. Okay, evaluate reverse Polish notation. Or is it Polish? You're given an array of string tokens that represents a valid arithmetic Alright, hold on. Oh, hello Nib. I've been trying to speak, but I haven't been, Yup. I always thought people could hear me, but people could not hear me. How is the Nib? This should work, honestly. I don't know why it doesn't. Let's see. Use test case. Run. Doesn't work on case 2 because it returns 12 when it should return 22. What does my program do? On the 60 div, let's see, 60 mod, sorry, floor divide, negative 121, negative, oh my god, negative 121 is negative 1 and not 0. Still doesn't make a difference to what I was doing there. I'm gonna get 10 times. Alright, let me do these operations. So 12 times 11, negative 11. Ooh. Man, I'm getting it so wrong. 121. Yeah, 121 is 1111. Okay, anyway, 60. Is negative 1. One, 3, 1. I pretty much have it. Okay, doesn't matter, I'll just go with it.
Hey everyone, welcome back, and let's write some more Neetcode today. So today let's solve the problem evaluate reverse Polish notation. Quite a mouthful, but basically this problem is about what the meaning of that term even means, and it's just kind of a way to compute arithmetic expressions. And the only operations we're really going to be doing in this case are going to be the simple ones: add, subtract, multiply, and divide. One note that they tell us, though, is division between two integers should basically round towards 0. Since I'm going to be doing this in Python, though, if you take some values and do integer division between them, they always round down, which is not rounding towards 0 necessarily, because imagine if we had -3 divided by 2, that's -1.5. It rounds down to -2 in Python, but that's not what we want to do. But there's a trick in Python that you can do to make it round towards 0, so we can take care of that. If you're using Java, though, I think it automatically rounds towards 0, same with like C++ in most languages. One thing we're told, though, in terms of the RPN expression, is that it's always going to be valid, which is good, so we don't really have to worry about too many edge cases. There's never going to be some divide by 0 or anything crazy like that. So now, what does RPN even mean? Well, let's take a look at this example. So we're given a 2, a 1, then a plus operator, then a 3, and then a multiply operator. Now the way this is going to work is we're going to be reading from left to right. We're going to be reading the inputs. So first one was a 2. Next one is a 1. When we reach an operator, though, what exactly are we supposed to do? Well, any operator in this case is going to be applied to the previous 2 values. And like I said, there's not going to be edge cases, so we're guaranteed that there are going to be 2 previous values. So in this case, hey everyone, welcome. Since I'm going to be doing this in Python, though, I'm towards 0, so there's never going to be some divide by 0 or anything crazy like that. So now, what does RPN even mean? Well, let's take a look at this example. So we're given a 2, a 1, then a plus operator, then a 3, and then a multiply operator. Now the way this is going to work is we're going to be reading from left to right. We're going to be reading the inputs. So first one was a 2. Next one is a 1. When we reach an operator, though, what exactly are we supposed to do? Well, any operator in this case is going to be applied to the previous 2 values. And like I said, there's not going to be edge cases, so we're guaranteed that there are going to be 2 previous values. So in this case, what we would do is replace this 2 and this 1 by adding them together. So it's going to be replaced with a 3. Right, so we can kind of forget these, and we already used this plus operator, so we can kind of cross it out as well. Now we have a 3 again, so I'm going to be kind of writing it down here just to kind of, basically say that we've seen that 3 before. Now we have the multiply operator. It's going to be applied to the 2 previous values. Now in the actual input itself, you can see that the previous value was a 3, and the value before that was a plus operator. When we say it's going to be applied to the 2 previous values, that's not what we mean. We don't want to apply it to another operator, right? We mean the 2 previous values that came. So you can see that we had a 3, and then the one before that was a 1. But remember, this 2 and this 1, they were replaced by this 3. And then we had a second 3, which we wrote down here. So this multiply is going to be applied to these 2 values. So we can multiply both of them and then replace them with the result, which in this case is going to be a 9. So you can see that that is our result, and you can see that it is correct. If you know the data structure, or you're familiar with the data structure, a stack, and you've used that in other problems before, I think this problem is pretty simple to figure out that a stack will be useful here, because basically each operator is going to be applied to the previous values, right? But in the case of this 2, the previous Hey everyone. So figure out that a stack will be useful here, because basically each operator is going to be applied to the previous values, right? But in the case of this 2, the previous values are going to be removed from the stack, right? And then replaced with the new value, which is a 3. So, as we read through the input, each value here is going to be added to the stack. Anytime we reach an operator, the previous 2 values are going to be removed from the stack, and then we're going to do the operation on them. So in this case, 2 plus 1, and then we're going to take the result of that, which is 3, and then push it back onto the stack. And that's kind of what I was getting at when I was doing the drawing explanation. So really quickly, let's actually run through an example with a stack, and just to make this problem a bit more interesting, let's replace this plus operator with actually a subtract, and this multiply with a divide, because it's going to be a little bit different with these two operations, because with plus, these two are going to be added, right? 2 plus 1. But when you have subtract, which order are they going to be subtracted? Well, the intuitive one would be 2 minus 1, because that's the order that they appear in. But 1 minus 2 could be possible, right? Well, in this case, if you looked at the second example, I think they clarify that, yes, it's going to be this way, right? 2 minus 1. Let's run through this with a stack very quickly. So we read the first value, it's a 2. We add it to our stack. Second value is a 1. We add it to our stack. Next, we get the subtract operator. What does that mean? That means we pop these values from our stack and then do the operation. So in this case, it was 2 minus 1. That's going to be a 1 over here. Next value is a 3. We add it to the stack. Next, we have a divide operator. So in this case, it's going to be the same order that the values appear in. So 1 divided by 3, we're going to round towards 0. So in this case, it's actually going to be 0, right? So we pop this, and then replace it with a 0. And we're guaranteed, since this is always going to be valid, that we're only going to be left with a single value in our stack. So that's the value we're going to return. So in this case, the answer is 0. So that's pretty much the entire solution. Now we can code it up, but I just want to mention that the overall time complexity is going to be big O of n, because we're just reading through the input string, adding each value to the stack, and removing it at most once each. So, the time complexity is 2 times n. In other words, it's big O of n. The memory complexity, since we do have the stack, is also going to be big O of n. So now let's code it up. Let's code it up. Like I said, we're going to need a single data structure in this problem, which is going to be our stack. In Python, you can just use a list. And then most of this problem is just going to be boilerplate. Once you realize that a stack works for this problem, then it's just about coding it up. So what we're going to do is just iterate through every character in our tokens input, and then just have a bunch of conditional statements. The first one is if the character, there's 5 cases, remember. It could be one of the 4 operators, or it could be any other character. And any other character basically means that it's a digit or some number, right? So let's basically make those conditions. So first is that it's plus, and let me just kind of, copy and paste this stuff and then get it updated. So the cases are plus, minus, multiply, and divide. And then the last 5th case is where it's something else. And if it's something else, that means it's a number. And that's the simplest case of all, because that means we can just take that character and then append it to our stack. But it's a character, remember? But we should probably convert it into a number before we actually add it to our stack, because remember, what we want to return is a number, not a character. Okay, so now let's start with the plus condition. Well, remember what I said? We can just pop from our stack twice and then add those values together and then append that to the stack. So for this, it's actually pretty simple as well. We pop from the stack twice, take the return values, add them together, and then append that to the stack so that the result is added to the stack. Pretty simple. And for multiply, that's also going to be almost the exact same thing, right? Instead of plus, we're going to be doing multiplication. So let's, just copy paste and then update that as well. It's going to be a little bit more tricky though for subtract and divide, because the order that we're popping it in is not the order that we want to apply that subtract and divide operation. So for subtract, well, again, we are going to pop twice because we want to get those 2 values that were popped. So let's do that. This is, let's call them just A and B arbitrarily. You could call them anything that you want. But when we subtract them, we want to take the one that was popped second and subtract it from the one that was popped first. So B minus A, and then take that and then append it to our stack. So this, though, is going to be very similar to what we do in our divide operation down here. We're going to pop 2 values, and then in that same order, B and then A, we're going to divide them rather than subtract them. But in Python, when you do this, this is actually decimal division, but we want to round it towards 0. So to do that, we can actually just call the int function, which will convert it to an integer and also round it towards 0 at the same time. So that's pretty much the entire code. You can see it's mostly just a bunch of boilerplate. But once all that's done, let's go ahead and return the single value that is guaranteed to be in the stack at index 0, and then make sure that our code works by running it And as you can see on the left, yes it does, and it's very efficient. So I really hope that this was helpful. If it was, please like.
Wow. Okay, so that was it. That was all it was. Alright. And I can copy this whole solution. And paste it in the Neetcode solutions. Oops, that's not it. Alright, easy. Alright, let's do this real quick because I just need to satisfy my typing. And then we'll move on to scheduler development. Alright. Oh, but I'm in the momentum of Neetcode. Honestly, feel like doing Neetcode all day. Generate parentheses. You're given an integer n, return all well-formed parentheses, strings, and that you can generate with n pairs of integers. Interesting. Three. One. Constraints 1 is less than n is less than 7. This is going to be interesting. Is that it? What do I do? What do I do? What do I do here? How do I actually think about this problem in terms of a stack? We have parentheses, one open parenthesis. Say you have 3 open parentheses in the stack. And then pop that off. What's up, Isaac? Jafar Isaac, nice to meet you. Thanks for joining. I'm just trying to do a Leetcode question right now regarding stacks. And if I can't figure it out, I'm going to just look at the solution. The problem with this question is, how would I actually go about generating these different examples? I guess the combinations, it's interesting, it's hard. If I can't figure this out, how would I usually do this? Started off with that. And then maybe remove 2. No. Started off with 3 like that. You definitely can't. Okay. No, I'm at a loss. So we're gonna just look at the solutions.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve generate parentheses. So we are given a pair, a certain number n pairs of parentheses, and we want to write a function to generate combinations of all well-formed parentheses. And so you can see that these are the examples, and by well-formed they basically mean like when you're writing code, you know, you're nesting parentheses.
Thanks Jatin Gamer, thank you very much. I'll keep on trying. We'll see how we go. How long do I need to spend on one Leetcode question? Let's say I mean the question that I did just before was 40 minutes, but that's me attempting the question before looking at the solution. But then sometimes with this question I just don't know where to start. I'm just going to have a look at the answers straight away. You know, I think it just stops me from getting blocked.
You want them to be nested in a valid way, right? Like we can't have a right parenthesis come before a left parenthesis, right? Like this could not be possible. We would have to do it like this, right? So you can see for each left parenthesis, we have a matching right parenthesis that comes at some point after it, right? So like in the first example, the first 3 are left parentheses, then the next 3 are right parentheses. And when they say n equals 3, that means we have 3 pairs of parentheses. So in total, we have 6 parentheses because a pair is 2 parentheses. And 3 are going to be open parentheses, and 3 are going to be closed parentheses, right? So this is a open parenthesis, this is a closed parenthesis. You can see that when n equals 1, there's only one possible way to make them valid, because this is one way and the other way would be this, and we know that this is invalid. So how can we solve this problem? Let's just try out the backtracking solution kind of, right? Like a sort of brute force approach. How would we even do a brute force approach? Let's say n equals 3, so then we have 3 parentheses. What does that tell us about valid parentheses, right? Like this is one valid parenthesis that satisfies this condition, right? We have 3 open parentheses, 3 closing parentheses. Well, the first thing it tells us is that we need 3 open parentheses and 3 closing parentheses, right? That much is pretty obvious, right? Like you could probably figure that out by yourself. If we have 3 pairs, then we definitely need 3 open and 3 closing parentheses. So in total, 6 parentheses. But what about the order of parentheses? So let's say so far I'm empty, right? We're empty. Can I start out with an open parenthesis? Yes, I can, right? But can I start out with a closing parenthesis? No, we know that this is invalid. No matter what I do now, this is always going to mess up our parentheses. So we can't start with a closing parenthesis. We can only start with an open parenthesis. Okay, but now let's say I have 1 open parenthesis. Now what can I do? Can I have another open parenthesis? Yup, because our limit is 3 open parentheses, and so far we have 2, so we're allowed.
Okay, which protocol do you follow with attacking the questions, or do you go randomly? Okay, basically from everybody that I know who's trying to go for big tech right now, they use Neetcode. Neetcode 150 is what it's called. So I think I didn't put it in the description on this stream, but if you search up Neetcode.io, I'll paste it in chat. And do the Neetcode 150 version. So if you go to Neetcode's homepage and then go to practice, there are these different core skills: Blind 75, Neetcode 150, and Leetcode all. The recommendation is to do Neetcode 150. And so right now you can see where my progress is at. But I'm going through them sequentially. Yeah. That's about it.
Allowed to do that. What about a closing parenthesis? Can I have a closing parenthesis? Yes, because so far our open count is 1, and initially the closing count is 0, and I can, by adding this parenthesis, I'm just changing the closing count to 1 now, right? So now let's look at it. Now can I add another open parenthesis? Yes, I can, because the limit is 3 open parentheses, and so far we only have 1, so I'm allowed to add a open parenthesis. What about a closing parenthesis? Can I add a closing parenthesis right now? No, because you see that so far we have 1 pair, right? This pair of open and closing parentheses, and then when you get rid of that pair, then we're just left with a single closed parenthesis. This closing parenthesis will never have a matching open parenthesis on the left of it, so we can't add this parenthesis. And how would you figure that out from code? Well, just take a look at the count we have so far. Before we add the parenthesis, we have a count of 1 for closed, we have a count of 1 for open. Basically, what this tells us is that we can only add a closing parenthesis if the count of closing parentheses is less than the open count. We can only if this is true are we allowed to add a closing parenthesis. So if, for example, if I were to add another opening parenthesis, now we update our open count to 2. So now we have 2 open parentheses, right? So 2 is open, 1 is closed from over here, right? So now I'm allowed to add a closing parenthesis, right? So basically, let's say if we're going to do backtracking, these are the 2 rules that we have to follow. This is basically our base case. Once we have 3 open and 3 closing parentheses, then we have a valid parenthesis formation, right? And this condition tells us when we're allowed to add closing parentheses. We can add as many open parentheses as we want as long as it's under the limit, which is n, right? We can add up to 3 open parentheses, but we can only add a closing parenthesis if the number of closings so far is less than the number of open parentheses. So with that said, let's start our backtracking solution. So far we're empty, right? So the first thing we're going to do is add a open parenthesis. So now this is what we are so far, a single open parenthesis. Since we added a open parenthesis, that means the count of open is greater than the count of close. So now we have 2 choices. We can add a open parenthesis or we can add a closing parenthesis. So we have potentially
Is this
2
not a
open
tree
parentheses
problem as well?
or
It feels
a
like
single open and a single close. Okay, let's take a look at this decision. Here we have open is greater than or equal to close, right? And the number of open is still less than 3, so we can do both choices. So from here, we can add another opening parenthesis, so we have potentially 3, and we can add a closing parenthesis, so 2 open and 1 close. From here, we see that the open and close count is actually equal, right? We have 1 of each. So here we don't have any choices. We have to add a open parenthesis. So what we're going to do is have just another open parenthesis come after. Okay, so I'm running out of room, but let's continue. So over here, now we have 3 opening parentheses, right? So we reached our limit, which is n. So we can only make 1 choice, and that's to add a closing parenthesis. So we're going to have 3 open and a single closing parenthesis. Here you can see that we have 2 open parentheses and 1 closed parenthesis. So we can actually add, we have 2 choices. We can add an open and we can add a close. So if we add an open, we'll end up with 2 open, 1 close, and then another open, or we'll end up with 2 open parentheses and 2 closing parentheses. Over here, we also have 2 choices because we see we have 2 open parentheses and 1 closing parenthesis. So if we add a open parenthesis again, we'll end up with open, close, open, open. If we add a closing parenthesis, we will end up with open, close, open, close. Okay, so we're almost done. Starting over here, we see we have 3 open parentheses, so we can only add a closing parenthesis now. So open, 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 close, close. From here, we actually only have 1 choice, even though we have more open. We have 3 open and 1 close, which open is more than close. So we should be able to add 1 of each, but we can't because we know that 3 is the limit, so we can't add any more opening parentheses. We can only add a closing one. So the new parenthesis we add is closing. Here we also have 1 choice. Even though we only have 2 open and 2 close, we know that the open count
all of
is
this
equal
makes
to the
sense so
closing
far, to
count,
be
so we
honest.
can't add another closing parenthesis because that would make it invalid, right? So we can only add a opening parenthesis, so we'll just add a single open. Here we also only have 1 choice because we already have 3 opening parentheses, so we can only add a closing parenthesis at this point. Here we also have 1 choice. We can only add a open parenthesis because if we add a closing parenthesis, that would make this invalid because then the close count, which would be greater than the open count, right? Which we cannot do. And so at this point, for each of these 5, we only need to add a single more parenthesis. And since this has 3 open, 3 and 2 closed. We know that we need 3 of each, so the only thing we can do is add another closing parenthesis to it, right? So this is going to be
we'll
one
see how we
possible
go
solution
when I
because
write
now
it
we
out.
actually have 3 of each, which is what we wanted. For this one, we have 3 open and 2 closed. So lastly, we are going to add another closing parenthesis. And you might notice that's what we're going to do for each of these, right? Because each of these now has 3 open and 2 closed, so all we need to do is add another closing parenthesis. And for this one, we also are just adding a closing parenthesis. And lastly, this one, we're also adding a single closing parenthesis. So now if you look at all 5 of these, you see that they're all valid,
All
right?
different, all
And
valid.
you see they have 3 of each, and they come in a valid ordering. So these 5 are going to be returned as our result. These are the 5 ways we can make valid parentheses. So now let's finally write the code.
Okay. Now, here's the thing. Before I can do that, before I even do that, even looking at this again, you know, he starts off with one list and it branches off to 2 different lists because there are 2 options, and then it branches off to another 2 lists because there are another 2 options. And just this branching part is also what I'm thinking how we do this. Okay. We'll think about it while we write some stuff. So he does have an open and close, but I'm not sure if that makes sense to be here. Let's just see the solution here.
This is basically what we're going to do. You can see I summarized it. So we're only going to add an open parenthesis if open count is less than our input n. We're only going to add a closing parenthesis if the closed count is less than open. And we're only going to stop adding parentheses altogether once our open count equals our closed count, which is going to equal n. So I'm going to do this recursively because that's basically the best way to do it. And I'm going to create a stack, which is going to hold our parentheses. And I'm going to create a variable result, which is going to have our list of valid parenthesis combinations.
Yeah, nice.
And I'm going to do this recursively. So I'm going to put a function backtrack inside of another function. So if we have this, then we don't need to pass in these 2 variables into our function because this is nested inside of here. We also don't need to pass n into this function either.
That's interesting.
But we are going to have to pass in our open and closed count. So I'll call it open n and closed n. So we know the base case is if open n is equal to closed n, which is equal to n. So in that case, we have
this was the level that I was thinking about.
Our stack will contain the proper parentheses. So what I'm going to do is basically some Python stuff, but you could probably handle this with a string if you wanted. You don't actually need to use a stack.
I think I know what he means by backtrack. Let's just see. Yeah, before I guess the other thing is, before I even finish watching the video, I try to write out what I think is going to do. And, okay. The result and the backtrack. So he writes if open n equals closed n, which equals to n. That means if all 3. Alright. Then I'm guessing he's about to write that we append that combination. That he's been keeping track of. I guess the other problem is, where do I keep track of that? So you append something. And in the problem, it's a list of lists, right? It's a list of, list of lists. But it's a string. Some string. Alright, let's have a look.
But I just like doing it. So what I'm going to do is take every character in the stack and join them together into a empty string. So once they have been joined together, they will form a complete string. And what I'm going to do is append that to our result list. And once I've done that, I can just return, right? Because this is our base case.
Right. So that string comes from the stack. And yeah, basically what he said makes sense. Join them to make them into a string. And then return. That's all good.
Remember, if we want to add a open parenthesis, we have to check that our open count is less than n. If that's true, what we can do is to our stack, we can append a open parenthesis. So just an open parenthesis, and then we can recursively continue our backtrack. But if we do that, we have to increment our open count by 1, and the closed count remains the same.
Ooh,
and after that backtracking returns, though, we do have to update our stack because we only have a single stack variable.
That's actually recursion.
Remember, we're not passing this stack into every single call. This stack is basically a global variable. So every time we're done with backtracking, we're going to pop the character that we just added to the stack. And if we want to add a closing parenthesis, we have to make sure that the closed count is less than the open count. So then we can take our stack and append a closing parenthesis, and then we can call our backtrack function, our recursive backtrack, except we'll leave open count the same this time, and we'll actually increment the closed count. And as before, we're also going to need to clean up, so we're going to have to update our stack by popping the character that we just added. And this is actually the entire function. So you can see we broke it up into 3 conditions, which I commented up here and I explained in the visual explanation. So the only thing we have to do now is call our backtrack function, pass in 0 for the initial open and closed count, because our stack is initially empty, and then we can return what our result will contain, which will be the list of valid parentheses. So as you can see, the solution works, and
almost
it is
like
pretty efficient.
There's a tree in here somewhere. You know, it definitely feels like there's a tree in here somewhere. Okay. Let me try and explain through it. Tab. Okay, so that base case condition when open and closed is equal to, say, 3 being the maximum number of pairs of parentheses, you then return that as a result. That means you've used all 3 of your opening and closing parentheses. Sure, that makes sense. The next thing then is if open is less than n. So if open is less than n, then you know you can add an open bracket. And if open brackets, right, you can add an open bracket, but then backtrack to the open plus 1. It would be good to actually have the image on the side to fully understand this, actually. Okay, but let's just do this as he says. Damn. Okay, so stack.append that, because you know you can add an open bracket if it's less than n, sure. And you know you can add a closed bracket if closed n is less than, so closed, the number of closed is less than the number of opened. And then the backtrack is the important part where it all makes the difference. Backtracking to open n plus 1 and then closed n plus 1. Because you've already now added that parenthesis. So if you've added that parenthesis, then you just add 1 to the backtrack function. And then the backtrack function is where it adds the results only at the very end when you've gotten open and closed. Yeah, that's a good definition. Like when you look at that, that's like a well-made definition of what we're trying to achieve. Yeah, man. I think, honestly, I'm just trying to explain it to myself to fully understand it, but it does make sense now. Backtrack. Let's see if I can actually write it without looking at that then. Backtrack. What was I going to say? What was I going to do? Okay, so open plus 1 and closed. Open and closed. Whoops. RD. Okay, open, closed. And after. Okay. There was one other thing there. Ooh, what was it? I am missing it. This is how you know you've messed up. Hello, Nib. Closed is less than open. Backtrack. Open, closed. Plus 1. What else? Besides calling the backtrack function. Res. I think I'm definitely missing something else. Let's have a look. Stack. The stack. Okay, the stack popping is one thing I haven't fully processed yet. So the stack pop, what does that mean? What are we popping from the stack? The stack starts off empty. We append that value. And and then we pop it off afterwards, after doing the backtrack. Is this almost like it's almost like a depth first approach? A depth first, a depth first search. I think this is a depth first search, because I was talking about a binary tree before. It was a tree, but I think what I was thinking of was the fact it was a tree, and what's happening here is we're appending the bracket, doing the backtrack to add more brackets, and that would be, in one execution we'd have all those brackets there first, and then we would close them all up. Once we've closed them all up, we would pop that value off, and what would that even mean? What would that even mean? It would mean that this stack would now be fulfilled, and you are popping it off means that you can now consider starts off with all these. You get to a point where you pop off these three, or you just don't have them after doing the backtrack, and then you pop this one, so that the next thing you can do is add a closed bracket, and then you would continue with that, and then a closed bracket and that. I'm not explaining it well, I know that, but I'm kind of getting it. So I think there's a depth first search in there as well. And what I mean by that is, if we look at the tree that he's created, this code that we just copied is pretty much going down, is executing like this. So it goes down this left side, depth first, then it goes down this one, then it goes down that one. And when I say down this second one, right, that was the second one here that I was thinking of. And you can only do that when you pop in the place where he popped, so after the backtrack. And so I'm sure there's a breadth first approach, but this depth first one is basically, it executes left to right. I actually don't know how to do this besides showing it by mouse, but that makes sense. All right, so I'm gonna write that down actually. Generations, enumerations. Sure. Okay, I think I've done enough Leetcode now. I'm going to be doing my open source app called Scheduler, and this is what it is right now. It's literally from a template, and I'm using this. This is an open source app, anyone could see it, and I'm going to just be building on top of what I already have. This link doesn't work at the moment because there's no new releases, but we have a staging environment, and this is what the app looks like so far, because it's literally just a template. But I got the CI/CD set up to automatically work. So that's the password, and I put some fake items, but I'm working on this as well. yeah, that's pretty much Neetcode done for today. I think I did like 6 questions total, which is quite a lot for me. Okay, before I continue though, let me finish this with stack.pop. Return the result. That's all good. Alright, done. Now the thing that I do is I have another computer on my network, home network, that I can SSH into, and I've set that up so that I have a, I guess, better computer to work with when I'm developing. And I also have that scheduler cloned already here. And instead of using VS Code, we're going to use Neovim. I haven't actually properly used this for actual development, but today I will be. So that's going to happen. I will just say that we can probably copy and paste the solution that I found into here so that I can mark it as done, basically. Okay, so okay, so Shift V to 22G. That didn't work. Shift V to 22G. Yank. Okay, there we go. Control Alt, Control V, submit. Oh no, I overlooked something hard. What did I overlook? Oh right. I think there was something about. Yep. I overlooked this. Actually running it, because this is only defining it. Backtrack 0 0 0 0 space 0 and let's say that's it. Okay, let's go back to line 2. Shift V the whole thing and go to 24, I guess, line 24. Yank. I'm just copying and pasting the whole thing. If I get this wrong, alright, we're good. So I'm going to also just copy and paste that into Leetcode as well now, just so I have a copy of it in Leetcode. I'll also do a quick monkey type session. I just need to satiate my desires with typing. It's just a smooth thing. Okay. That's fine. Generate this is pretty cool, just saying. Alright, let's do a quick monkey type. A Leetcode monkey. Hell yeah. Ma. I gotta try and use something more. No, yeah, I gotta use my option key more. $42 words per minute. You just spent $81 on Steam. I'm pretty sure your money's going down the drain, Nib. Not because it's Steam. Just saying. What did you buy it on actually? Soup. Beautiful soup. LXML. LXML print soup h1 print line break soup.p all href soup find all a all href l href for L in all href print line break all href. Alright, I'm okay with that. I bought Tekken 8 and Steins Gate game. Epic. Well done. Tekken 8 and a Steins Gate game. I wish I knew what that was. Okay. Exit. Alright, back to now the scheduler development. Okay. We'll keep these open for now. But we can close this one. What are my GitHub inbox notifications? NA10 updated. Sure. Okay. Actually full screen this. And it looks like a mess right now, but watch this. What do I do? It's like I wish that beautiful soup was what? Beautiful. Well, this is going to be beautiful. After I do the following command that I hope to remember. Control W. Nope. Control W. Equal sign. Yes, it all just equaled itself. Okay. Now I need to open a terminal session. Oh, actually, whoops, I just quit. Not what I wanted. I do want to open up a tmux session. I don't think I have one right now. And that's where I'm going to open up Nvim. And I'm going to open up a, let's see. I need to open up a terminal. However, the only way to do that is if I remember how. It'll be a leader, H or V. If I want a vertical or a horizontal terminal, it'll be a H this time, except which is the H button. Okay, I got it right. Okay, that's good. And then docker compose up D, or just up, and then to exit this terminal window, Control X, and then Control up. It's a bit of a still learning. While I learn Neovim, I should put that in the title just in case. Okay. All right, let's try. Now, what I wanted to do so I create an item, half page down, half page down, half page up. So I created some task models, but I need to create tasks. I have CRUD there on the side. I want to change that to, yes, this is the page. And I want to create new line, and I want to use one as reference. And to use one as a reference, we probably want to open up another page. So what I'll do here is Control W, whoops, that's the wrong thing, Control W, and we want a vertical window, so V. And in this vertical window, I want the items route, so I can get some inspiration here. Basically, you might be able to tell that I copied and pasted some parts of this, like tasks public, items public. You can tell from the middle and the most right. But essentially this is what I need. And I'm also still learning about this, so it's a good learning experience. And okay. read item is the next thing that I want, most likely, and create item and put item. Okay. The main thing also is I get to learn how to, I get to train my writing as well, just like what I do with Leetcode. Some ID. What in the world? Okay. Oh, yeah. Okay. If you guys don't know what just happened, I got disconnected from that server because that server just turned off because it's 5:15 here. And I can turn that back on, but it means it's an automation that I have to turn on and off the computer. And the only reason why I have that is because the computer was only meant to be on at certain times. And usually 90% of the time I'm not using that computer, so it'll just automatically turn it off at that specific time. But right now, I just turned it back on and we just gotta wait like 20 seconds. And then it'll come back alive. After I copy over those functions, train my typing, I might do another Leetcode question. I'm kind of obsessed with it today. Oh, so found a swap file owned by me. Another program may be editing this file. If this is the case, be careful. An edit session for this file crashed. If this is the case, use recover. I think it recovered. All right. And let's see. Okay. There we go. We just got to rewrite that small part, which is fine. Router get ID. I'm going to put on some background music while I write this. Okay. Hello, Prayash. 是什么? Nice to see you in the stream, Prayash. Hopefully your day's been alright. Task public. Read item. Read task. Session. Session dep. ID int any get task by ID. Task ID. So this task here is just that. Task base, which is an integer, owner ID and owner. Okay, and then I was scrolling through the home page and got the stream recommended. What are you programming, by the way? Well, that's actually pretty nice then. Thanks for letting me know that I'm actually being recommended. Secondly, what am I programming right now? It's an app that I'm making that I'm very early stages in, but it's public and everyone can view it if they want. It's a scheduler app, and my thinking is, I don't know if you've heard of the app called Motion, but I kind of want to build something similar to that but open source. And so because it's, you know, free and open source, it's public, anyone can see what I'm writing, it'll be good, hopefully, and maybe get some traction later down the line, when it actually pops off, maybe. But yeah, so it's early stages though, like really early stages. I've got basically this as a template from another project called Full Stack Fast API Template, and I'm using Python as the backend, which is what you see here. And Python as the backend means you use Fast API. Or when you use Fast API, you're using Python as the backend. And right now I'm just copying some boilerplate code into my own thing of what I need, because say right now I'm creating a task, that's what I want. And then later, you know, there's tasks in Motion. I create a task, then I can automatically schedule that into a calendar format. But that's a dream that will have to come after a lot of coding. So I'm guessing, you know, this will take some time. Probably like more than a month of focused work to accomplish. But I have all the time in the world right now. There's no study, there's no work, pretty much because I haven't been working. That's another story that I won't get into right now, but I'm not working right now. So I have to fill my time with something, basically. And this was something that I thought, I guess I got inspiration from another open source project. Okay, task equals session get task ID. If not item, raise HTTP exception status code no Task not found. If not current user is super user, and item.owner does not equal current user.id. Basically, the current user is not a super user. Not enough permissions to view the task. That makes sense. Although mentioning it as a result of not having enough permissions, I guess it's it doesn't necessarily mean that there is data of that kind there. It's just telling you you just don't have enough detail. Not enough credentials. I don't know what I'm saying. Permissions. I see, it seems great. Why are you creating something similar like Notion? Have you thought of any new and cool features the app will have that will be unique than any other website app like Notion? Okay, so I actually might have pronounced it wrong, but I mean motion. So starting with M as opposed to N. So Notion is, yeah, I know Notion, but I don't think Notion's going to be my plan. I think I'll go for motion because at the moment there's no open source project that I've seen that basically implements motion. You know, there's open source projects for Notion. There's equivalents like all over the place, but my main goal is to have a open source version of some product, right? And one that hasn't been done yet, from my understanding, from my research, basically just looking at the web, is that motion doesn't exist. So, you know, in terms of what motion is really, you know, I had a little suss of what their thing is. You know, they have this calendar view, and the idea is you put tasks on the side, you just write your tasks down, and you want to basically automatically add them into the calendar view. And that's that's kind of what I want to create. You know, this says it's your AI assistant, but I don't see how it could be AI as opposed to just algorithms, because I'm pretty certain this is probably at most using machine learning and just flat algorithms. And there's nothing AI about it. The language they use in this TikTok, for example, this TikTok ad, for example, is literally like in the first half second, they show you AI or some chip with a brain. There is no brains, I don't think there. Except in the machine learning, that might be there. And I'm basically saying it's not AI because it's probably just machine learning. That's my, that's my guess. And even still, when I say machine learning, it's a little semantic it's a little philosophical, because what people are calling OpenAI AI is also technically machine learning. And that's another thing I'm just blabbering on about right now, but yep. Basically, I don't think OpenAI is actually doing full AI. What they're doing is only narrow AI, I guess. Yeah. And wait till they get to AGI though. Actual AI with, I guess, logical processing and something that can actually solve math, for example. Yep, anyway, that's a big tangent. This is the actual app, Ocean. And I want to create something similar. But very, very early stages. So, you know, you can watch the GitHub repo to follow along if you want, you know. On any releases, maybe I'll try and get some people to help me as well. You know, or you can even help. Really, it's just yeah, anyone can help out. Okay. Alright, return the task. If not item, if this, technically I feel like this operation should only be done, like I feel like this operation could be done before you even get task, you know? If you're not the owner, okay, wait, you can't. Because we're talking about an item, okay. Valid. CIW. Yep. Okay, if it's not a super user, you know, technically I could just move that out in front there, but alright, don't worry about it. I think I'm fine with that as is. Create task. I guess before I even do that, I want to have a look at it a little further. Ooh, I'm not even looking at the right thing. Okay. Create item. Create task. E. Yeah, Notion's the big one. So yeah, everyone knows Notion, but I don't think many beyond the ads for Motion, nobody knows Motion. Oh, I ended up autopiloting. Another thing is, it's the battle of autopilot prevention. I don't want to autopilot here at all. Let's see.